So we want to introduce you to the idea of graphing quadratics when given in different forms. So this right here is a factored form, and if I wanted to graph this, the cool thing is this form tells me what the x-intercepts are. So to find them, we say, well, x minus 1 equals 0 and x plus 3 equals 0. Because when I'm multiplying two things, as long as one of them is 0, the whole thing's 0. So that's where it will cross the x-axis. And so to solve on this one, if we add 1 to both sides, we end up with x equals 1. To solve this one, if we minus 3 from both sides, we get x equals negative 3. What this means graphically is that we have our x-intercept, our y-intercept, putting some lines on here, we end up with x equals 1 and x equals negative 3 as our two x-intercept points. Now, if we want to find other points to plot, we would then have to plug points in or factor it out. So plugging, say, 0 in, so if we plug 0, we get y equals 0 minus 1, 0 plus 3. So negative 1 times 3 equals negative 3. 1, 2, 3. So 0, negative 3 is a point. If we plug in negative 1 minus 1, negative 1 plus 3, we get negative 2 and 2, which equals negative 4. So at negative 1, we get negative 4. And this actually happens to be the vertex because midway in between our x-intercepts, so if we come midway in, that is our vertex. So we can then go ahead and put our quadratic through it. So now if we wanted to list a couple of things, let's say we wanted to list first off the line of symmetry. Well, the line of symmetry is what cuts the graph in half. That always happens on the vertex. And that vertex has an x-coordinate of negative 1, so x equals negative 1 would be our line of symmetry. Our vertex would be this point, so vertex would be the point negative 1, negative 4. Our x-intercepts we found at the beginning, which are 1, 0, so this point right here, and negative 3, 0. And if we wanted to list our y-intercept, sorry, this is getting down low, y-intercept, that's the point that crosses the y-axis. And so our y-intercept is this point right here, which happens to be 0 and negative 3. So that's when they're in factored form. So now let's say, well, what happens when we have it in a different form? So what if I have a same quadratic, or a similar quadratic, but instead of factored form, we have it in vertex form. So first off, right off the bat, vertex form, the vertex is right here, but this point is opposite of what you think. This point is the same. So our vertex happens to be negative 2, negative 4. So opposite, the same. So if we come to negative 2, negative 4, put our first point, that's our vertex. We also know something. Because this front number is positive, this thing opens up. So we know that much. So if we start, we can plug in points. That's one way to go about this. So if we plug in something like 0, we would say 0 plus 2 squared minus 4 is 2 squared minus 4, or 4 minus 4 equals 0. So when I plugged in 0, I got 0. Because we know this thing is symmetric about this point, if you came 2 points this way and got 0, that means if you come 2 points this way, you'll also get 0. And this thing opens up, so it comes just like that. Now, to list some things, line of symmetry. We would say the line of symmetry is this x coordinate on the vertex right here, so x equals negative 2, so it matches the vertex. We've already listed the vertex. X-intercepts are these 2 points, so the first one is 0, 0, the second one is negative 4, 0. The y-intercept is the same point, so 0, 0, because that's where it crosses this line as well. And so depending on the form we're given the graph in, either vertex, or earlier we saw factored form, we can find the same pieces of info, it's just displayed in a little bit different manner.